All right, thank you very much for letting me talk today. And I think I might be representing the diversity that Jim talked about earlier, in the sense that I sometimes call myself a health economist. And when I'm typically in those circles, I'm usually trying to convince people why they should be putting more structure on their models. But maybe now I'm going to be having to defend myself on why I don't have as much structure in this model. But maybe Steve helped me with your discussion about why some of the things that I might be able to do with without estimating the primitive parameters. But obviously some things I can't do. And I'd also like to thank my co-authors who are also health economists, Una Han and Edward Norton in Michigan. So I'm going to skip this. I'm going to run out of time anyway. So, but basically, I'd just like to point out that I think a lot of the topics that Jim and a lot of the different groups that are associated with the human capital and economic opportunity group emphasis is trying to answer some of these questions about life cycle behavior and impacts of life cycle initial health or initial consequences on later life outcomes. And so I think one of the things that several of the questions that we might want to ask is, how do we empirically capture something that's evolving over the life cycle and its impacts on health? And then specifically, what are the avenues? And I think that's what a lot of these papers have been about, is trying to identify what avenues over the life cycle affect individuals' behavior. And something that I would love for you to give me feedback on is, once we have a model, what can we do what are the outcomes that you want to see? What do we have to look at? And by the time we get to the end of this talk, you'll see what I'm struggling with in terms of telling you what I've found. So what do I mean by health on the health side of health influencing productivity, and consequently the reverse, productivity affecting health? We can think about self-reported health. That's what Rong used in her analysis over time. But we can also think about the development of illness or disability. And so there have been some papers that have looked at that. But we might want to think about chronic conditions, and especially when we're thinking about productivity. I've heard that among employers, they say one of the largest problems with the workforce in terms of reduced productivity is because of sleep apnea. It's one of the largest contributors to not being productive while you're at work. But then obviously a lot of people are thinking more about mental health issues. And so let's even think on the other side in terms of productivity. We know that they're important. Cognitive and non-cognitive skills are important, so we might want to think about health's impact on those. And I'm thinking here specifically, if we're going to be ultimately talking about BMI, might BMI influence my self-confidence? And so that self-confidence might translate into my behavior at work or something. But we might want to look at employment at just the extensive margin, but we might care about things at a more intensive margin, so wages, or even things like absenteeism, short-term disability, and presenteeism. Presenteeism is that going to work but not being 100% productive while you're at work. And the reason why I bring these up is because, again, we're trying to think about life cycle health, so the impacts of health over the life cycle. And in order to do that, we need good data, because we're really not going to be able to follow individuals over time and know something about their sleep apnea and the impacts on its presenteeism. Data sets just don't exist for us to be able to do that. So I have to be able to answer these questions in the context of what I have. So we're going to change all of those to say what we're looking at today is the impact of body mass on wages, because I have a data set in which I can follow individuals over a long period of time and have those variables. So I'm going to skip why body mass may not be a great measure of health. And the other thing that I want to point out is I've got my health economics hat on right now. So I'm going to think of body mass as a measure of health, all right? And then we can talk about what it might also be later on. All right, so these are data from my sample from the NLSY 1979. And the reason why, let me just tell you what this is. This is age on this axis. This is white females and black females. So this represents the distribution at each age of body mass measured by the body mass index. I'm assuming that most people are familiar with that. If you're not familiar, below 25 is considered normal, between 25 and 30 is considered overweight, and above 30 is considered obese. But the thing that I want to point out here is that black females spend, on average, a majority of their life, and this is obviously only to 20 to 45, but a majority of their life during those ages in an overweight state, and a good 30% of them are actually obese for much of their lifetime. It does drop down at older ages as individuals' body mass falls. I used to, in a previous version of this paper, we were looking at males and females, and so I showed this exact graph, but instead of having white females and black females, I had males and females. And one of the things that was quite evident from the data, and that I vocally described when I was talking one time, giving a seminar, was that obviously it shows that women have more mass in the tails. And then I realized that I should probably not say that anymore. So we'll just skip that and keep going. All right, I'm not going to talk about how body mass distribution has changed over time. There have been papers done that try to explain why we've seen this distributional shift over time, but that's not really the focus. I want you to think about how the evolution of body mass within a person's life cycle is influencing their productivity. So again, I don't want to talk specifically about the literature that's looking at the effect of body mass on wages, but I just want to point out that there is some evidence of a wage disparity, but that evidence that's being shown is a contemporaneous effect, so it's holding everything else constant. Do we see an effect of body mass on wages once we've controlled for education and experience and other things? So we do know that there is evidence of that in the literature. So what exactly is this, all right? And this is where there are some interesting questions to ask. As a health economist, I would like to think that maybe it is differences in productivity. Individuals, all else equal, who are less healthy, all right, might be less productive at work. And so that might be what it is capturing. But it might also be capturing some unmeasured human capital investment. So we might only be able to control for schooling or maybe degree attainment or something like that, but we might not be able to control for other measures of education or human capital that might be influencing it, and that would obviously have to be correlated with health in order for the health variable to pick up.
You look at different occupation and, for example, exposure.
Okay, all right, wait 1 second, okay, and I'll answer that question. All right, so it may be that it's capturing individual preferences for particular occupations or even just for employment if that's not captured by some of the other measures that we have that capture the experience aspects of human capital. Unmeasured productivity, that may be similar to the first one, that it might just be picking up those observed differences in productivity. But another important one that a lot of people think about is that it's related to employer preferences. So it may be that if an employer believes that your unhealthy state would lead to higher expected health insurance costs, then he may penalize you by offering lower wages or something, or you may be less likely to be employed at the extreme. It may also be the case that there are particular occupations where it's important for the individual to look a certain way in order to get people to buy their product or something. And so there might be reasons why an employer might pay somebody less if they don't have those characteristics. But it also might just be taste discrimination. And so this is what a lot of people are thinking about, is body mass is actually picking up a beauty aspect, and that there might just be discrimination based on taste, and not necessarily employer preference or bad employer preferences, right? As opposed to employer preferences that we might defend. I am not going to be able to distinguish between these. That's not the goal of this paper. The goal of this paper is really to say, is there, once I do a lot of things econometrically, is there really an effect of body mass on wages? Do we really find that? And what is that effect? I would love to answer these questions, but I think especially the last one would require an equilibrium model, a search model, or some kind of matching model or something, and I'm just not prepared at this stage to answer that. So, body mass evolves over a lifetime. It's going to indirectly, or I believe that it will indirectly affect your accumulation of many state variables that influence wages. So your education, accumulation, your employment or work experience, and whatever productivity is, all right? We don't have data that says how productive you are. Back when we were using piece rate wages or something, we might have had measures of productivity, but right now we don't. And so I'm going to assume that productivity is captured by your health, your marital status, and your children, right? So histories of those things. But the other thing to point out is all of these are accumulated stocks, all right? So we're not just endowed with a certain level of education at the beginning of our life, and then that impacts our wages over time. We accumulate education over time. We accumulate work experience over time. We become married, or we're married for X number of years as that accumulates over time. And so it's possible that BMI or body mass or health is influencing those decisions, and so that's what we want to try to capture. So this is going to be the theory, right? But I'm going to use bubbles. If you would like to see the math, it's at the end of the slides, right? There is an optimization problem written down, but this might be the easiest way to depict it right now because I'm not parameterizing a utility function or an expectations process. And so this is just an easiest way to show it right now. What I care about is well, think about this as a timeline, all right? So in period T, I might observe some wages. What explains those wages? It might be a function of your body mass coming into the period, but it's also going to be a function of a whole bunch of other things. Your history of schooling, employment, marriage, and children. That's going to be your information coming into the period, all right? So in other words, your state space coming into the period. Those are obviously endogenous.
Do you think you have children as affecting the probability, the productivity of a person? Or it's a measure?
Well, I can say, having 2 kids, that it definitely affects the productivity of the individual. But yes, I mean, it's an empirical question, all right? But I would like to suggest that they, in the model, they take time. Right? Taking care of children takes time, and so that takes away, you got to allocate your time in other ways.
There's actually a job market candidate from Northwestern this year.
Uh-huh.
She's trying to explain wage differences, and she claims she finds that wage differences for women with children are explained by productivity.
Right, okay. So I'll cite that. Okay, so, but wages we obviously only observe if the individual works, so we have to model the employment decision in period T in order to model that selection. But if we're modeling that selection into employment, we also have to consider the other choices in that period of whether to go to school, whether to get married, whether to have kids. And so, which is great that we have to model that, because that's going to exactly give rise to the state variables that we're accumulating over time. And so, okay, fine, so we have to jointly estimate all of those in period T. We're going to let body mass coming into the period influence those decisions. So again, if you want to look at the model, you can see that your health might influence your preferences for different things. Your health might influence the marriage market, for example, so your arrival rate of offers. There are things like that embedded in the problem. We then have to model the evolution of body mass. So body mass at the end of the period, which you're going to take into the next period, is a function of your body mass coming into the period, as well as your caloric intake and your caloric expenditure. So we've already talked about some problems associated with data sets. Well, there are not data sets that follow individuals over time that have calories in and calories out, okay? So I don't observe those important inputs that influence endogenous BMI accumulation. So what am I going to do? I'm going to substitute what those would be a function of with a timing assumption that is, I make my choices about schooling, employment, marriage, and children at the beginning of the year, and then I eat and exercise over the year. All right, so conditional on those choices and the cost of education or the cost of raising kids or something like that already taken into consideration. So those things are going to also influence body mass, incorporating your wages. And obviously prices have to come in there somewhere. And what's nice about not estimating the primitive parameters of this model is that I can include a lot of the things that Steve mentioned in his last comment about Rong and Jim's paper. So I'm going to call this influence the contemporaneous effect, and then call the influence of BMI or the indirect effect of BMI through these other wage determinants. Yes?
So do things fall apart here if wages actually reflect productivity from last period?
Fall apart in the sense of
Identification.
in the body mass equation, you're saying? Yes and no. It's a function of, well, no, because you're talking about the same thing that you were suggesting in terms of how to model wages. All right, so I want to think.
About the time and how important it is that that's right.
It's not important, and we kind of talked about that walking, that I could do it a different way. When I'm trying to sell this to non-structural people, the identification has got to be clear, and so they want to see what is exogenously changing, and so I usually have to try to sell that time assumption, but I don't have to do that here. Okay, so what does the model have? It's got 20 years of data on the same individuals, so it's not repeated cross sections. We're following the same individuals over time. It's going to be a jointly estimated model of 17 dynamic equations that are going to be allowed to be correlated through both permanent heterogeneity and permanent individual unobservables and time-varying unobserved individual unobservables. And we're also going to use, we're going to estimate the density of wages and BMI as opposed to just the expected value, which is what's typically done by labor economists when they estimate the log wages, for example. But we have seen some people here that have modeled the whole distribution. But clearly the whole distribution is interesting because that's the way we think about the theory, as individuals are getting a draw from this distribution of wages, and that's what I want to identify, and so that's what we're trying to pick up with this estimation method. So the sample is going to have 3,213 females, both black and white. There is some attrition from the sample, but I'll be jointly estimating the attrition, so it might be the case that individuals in poorer health attrit from the sample first or something. This is where I like to think of it as health. I don't know if body mass makes you attrit from a sample, but if you think about it as a health measure, it might. Okay, so let's just look at the state vector that I'm going to be able to use in this model. In all the models that we've seen, people have kind of had to limit the state space because it impacts computation. But in this model, even though it is rather computationally intensive, I can include a lot more about the history of the individual's choices. So in the bubble diagram, it was the whole history of behavior, but I'm not going to include body mass in time t minus 1, body mass in time t minus 2, body mass in time t minus 3, even though that is the whole history. But I'm going to summarize it by a few things. Yeah, Ronnie?
So body mass is correlated with health, as you're talking about, and I was wondering whether if in the case in which you wanted to identify more clearly the impact of body mass on wages, have you experimented with also controlling for other measure of health in the same model to try to?
Oh, so to say, okay, so two individuals might have different body weights, but report themselves in excellent health. Yeah. All right, that would be great. These data, yeah. Unfortunately, NLSY, especially NLSY 79, does not have good health measures at all. So weight and height are really the only measures that we have in that data set. There are a couple of years in which they asked a few questions, but not consistently over time. Okay, so I'm going to use body mass coming into the period. I'm going to use whether you were ever overweight, whether you were ever obese, and again, you can think about the optimization problem about why that might change your choices. And in this case, it's just an empirical question of does it matter? We're also going to include standardized deviations from the mean BMI in year T for your race. All right, now this was something that I was talking to a colleague of mine who listened to my whole story about what was going on here. And actually, it wasn't a colleague, it was a friend. And she said, I know what's missing. And I was like, what? And she said, social capital. And I was like, what is social capital? And so she goes on to explain to me that there are, how do I put this in a way that doesn't get me fired? Say in the marriage market, blacks versus whites, apparently there are preferences for different body styles. all right? I'm just repeating what was told to me. The other thing that she said that I thought was interesting is she thought that perceptions of individuals might be different based on their body size by race. So in other words, if a majority of black females tend to be overweight, then if you see an overweight female, it's just natural. Whereas if you see a black female, if you see a white overweight female, when the perception might be that they're lazier because they're not taking care of their health, and that might impact wages or employment or something. Again, it's an empirical question, so I can create this variable, so I did, right, to see if it matters. All right, schooling history, we're going to include whether you're enrolled or not the previous period, the number of years, this is schooling attainment or level of schooling, whether you were enrolled 12 or more years, whether you were enrolled 16 or more years, hopefully to capture degree attainment. We know in the NLSY data that we know degrees, but that would be another endogenous variable, so I'm just capturing it by the years of schooling since I'm modeling that every period. And then again, I can throw in whether this is your first year of college, because we just want to see if there's a freshman 15 effect, all right? Turns out that there is not, but I can put it in there. In terms of the employment history, it's going to be whether you're employed or not last period, whether you're employed or not in a part-time job last period, your accumulated years of experience in full-time work and your accumulated experience in part-time work. Marriage history is whether you're married or not, how long you've been married if you were previously married, and how long you've been single if you're previously single but ever married. Children history is, so what I'm modeling every period is whether there's a change in the number of kids in your household. All right, and so the choices are it can go down, it can stay the same, or it can go up. You might be asking whether I care about births, because obviously giving birth is going to impact the body mass of these females. That's in the NLSY data also, but again, that would be another endogenous variable that I'd have to model. It turns out that about 90% of the people have no change in the number of children in the household in any given period or transition in 1 year. About 20% lose children in the household, and that's mostly the children just age out of the household, right? About 80% of the increases in children is associated with births. So if you want to think about this as just a birth, you can think about it as a birth if you want to.
Well, why aren't you allowing for example, very young children that have a different effect than 50-year-olds?
All right, and that would be in the data, but I don't. I'm just modeling the accumulation of children. So, and I do have an initial condition. I do have an initial condition for the number of children when you first. Does that mean how much time I've left? Yes. All right. Initially, how many children you're observed with. So if we thought of this as births, then I could think about, okay, there's some probability that this is a young group. But some of these additions are through marriages, and so you get 3 more kids in the household because you married somebody with kids. And again, I might know the ages in the data, but I don't know what to do in the model about what the arrival rate is of kids of particular ages. All right, so I don't have that in there, but that is important. I could have the number of years since you last had a change. I mean, that's something that I could keep track of, right? Which might be a birth, which would be years. So this is the omega is the set of information that you have coming into the period. So the x's are just the exogenous individual variables. Some of them are time variant, some of them are not. But we also have to include prices that would be in the economic model explaining your choices. So this is a whole host of things that we include that vary at the state or the county level. I'm not going to go through what they all are, but they're related to each of the different choices. And again, like I said, if you want to see the optimization problem, it is written down. Okay, so what is the set of equations that we're estimating? So it's whether you're enrolled or not each period, whether you're employed full-time, part-time, or non-employed, whether you're married or not, and this change in the number of children. This is just telling you what the endogenous variables and the exogenous variables are. We're also going to estimate wages. I don't think we need to go to the wage equation, mainly because I'm going to be doing it using conditional density estimation. So the wage equation I would show you here is just log OLS, or log of wages. but it's just a function of the endogenous state variables coming into the period. I am going to interact each of these with the black indicator, so there's going to be a different marginal effect of schooling and experience and BMI, et cetera, on wages. There's going to be a body mass equation conditional on your choices in the current period, an attrition equation, and we got to account for the fact that these state variables aren't all zero when we first observed the people. So all those
Independent errors across the board?
well, I hadn't got to that yet. Hold on. This is the unobserved heterogeneity column, which we'll fill in a minute. All right. So first of all, actually, I think that one's next. So I haven't told you how, I told you I'm using conditional density estimation to estimate these equations, but let's talk about the heterogeneity. So each of these decisions, or each of the 4 decisions, and the production function for health, and the wage equation, and the attrition equation, everything is correlated, we allow to be correlated over time. So we might think of some permanent unobserved individual differences that might influence these choices or influence the evolution of health, or some time varying things. I just gave you some examples here of what those could be. So the way that we're going to model this is let the error terms, so let's just say U, E just stands for each equation. Who asked me that question? Lance. And we're going to decompose that error term into 3 different components. One that's going to be a permanent unobserved heterogeneity component with a factor loading on that, one that's time varying with a factor loading on that, and then an IID component. We actually estimate the distribution of these, so we don't assume joint normality or anything. We're going to let the data tell us what the distribution discretely by estimating the mass points of both of the 2 different distributions and estimate the weights on each of those and the factor loadings with some normalizations where necessary. Okay, oh, that's what that all says. All right, how are we going to estimate wages and body mass? These are both continuous variables. If in the health literature, this actually, Tom Mraz and I wrote a paper that we looked at health expenditures. And if you think about the distribution of health expenditures, there's a large mass at 0 and then a very right skewed distribution. Looks kind of like wages, obviously. Well, there's kind of a mass at 0 too for, well, observed wages, but that's the selection equation. But it kind of has a similar shape in some ways. And what in the labor literature, everybody estimates log of wages, but in the health economics literature, they start off estimating log of health expenditures, but they always retransform back to levels because for some reason you can't go to Washington and talk in logs. You have to retransform back to levels. And so there's this big literature on that. But one of the things that the conditional density estimation allows for is just for us to estimate in levels, even for wages, so we don't have to worry about that. Oh, but anyway, we can do OLS and we can recover the impacts of Z, in this case, on the expected value, but maybe we might care about different effects of particular variable Z at different points of support of the distribution of wages or of BMI. So that's what we want to do. So what does the distribution look like? 17 minutes. In red is the distribution of wages. This is dollars per hour of white females, and outlined in black is the distribution of wages for women. You can't quite see this, but it's about on average $9.60. This is in $2,000 and $11.44 for white women. All right, so how are we going to estimate it? Think of the distribution like this. I'm going to go through this mainly just because it's really easy. All right, maybe kernel density is really easy to do too, but I don't understand it. All right, so the conditional density estimation is like, it's really, really easy to do, and so I'm going to try to promote it. All right, so think about any partition of the support of the distribution of wages, and so we might care about the probability that a wage falls between WK minus 1 and WK, right? And so we know that that's just the integral under that density from those 2 different points. All right, so we can think about what the hazard function is, or the probability of a wage falling within a particular interval conditional on not falling in an interval prior to that. And then we can use that hazard to construct the probability of it falling within that interval, all right? And then once we have that hazard function or have that probability, then we can just use that as the weight on, say, the mean wage in a particular partition, and then we can recover in this case, the first moment of the wages, but we can recover any moment of the distribution that we want to. Note that this method allows the z's to impact the probability of being in a particular partition, okay? And so that's where we can get different effects of body mass on wages at different levels of wages, for example. So how do we do this in practice? We pick a value of cap k, all right, so this is the number of partitions that we want to use. And we're going to actually test that, all right? We don't just pick it out of thin air, but we might start with a particular level. So let's just think of 10 different partitions. And so I've actually put on here the cut points associated with that, such that 1/10 of the observations fall within each one of those partitions. All right. We know that the hazard, or the probability of being in a particular partition conditional and not being in another one, is simply 1 over cap k minus 1. All right. One nice thing to think about is if cap k is 10, and we have not fallen into the up to 14.59, all right, we're not in the previous 8 partitions. All right, we've got 10 minus 9 minus 1, 10 minus 8, 1/2. All right, which in other words just says if I haven't fallen into wages into a partition prior to 14.59, there's a 50% probability that I'm going to be in either one of the other ones. This is unconditional on the x's, all right, or z's in this case. And then obviously, if I haven't fallen into the first 9, then the probability is 1 that I'm going to be in the last one. So we can define a cell or an interval indicator that's equal to this continuous function. And then if we just did a logit of that parameter, we would recover those probabilities, right, the hazards of being in there. So then what we're going to do is take the data, replicate it 10 times. So for every person year, we'll replicate the data 10 times, create an indicator variable for which partition your wage falls into. All right, and then interact this interval indicator with all of the x's or z's, whatever I'm calling them now, with all of the explanatory variables, all right? And then estimate a logit, which will give us the conditional probability of being in a particular cell, right? So very, very easy to estimate. It's just one logit. It's hard to interpret the parameters because these are now these weird hazard parameters, so you have to simulate to really understand what's going on, but it's kind of nice. Okay, so we're going to use CDE both on wages and on this BMI index, right, where normal is 25. 13 minutes, I'm doing pretty good. Okay, so what I wanted to first show you is that with our data, we can get back what we see in the literature. All right, most of the literature is done with repeated cross-section data. Even most of the analysis that has panel data doesn't exploit the panel data nature of those data. All right, so I'm just going to take a little bit of time on this column. This is just a very, very simple model, OLS on log wages, no correction for selection into wages, all right? We're just going to make it a function of the x's that are in my model, which are just the exogenous variables, none of the endogenous stuff, and body mass. I should also point out that in this case, body mass is treated as exogenous. Explains about 28% of the variation. If we do a simulation or calculate a marginal effect of going from overweight to normal weight, so I like to think about this as an improvement in health, and this is going from 27.5 to 24, so about a 3.5 point difference in body mass points, that we see a 31-cent increase in hourly wages for white women and a 8-cent increase in hourly wages for black women, and these are statistically significant. So then all I did is I just added in the variables that I thought are important in explaining wages, again treating them as exogenous, and we see a little bit of a decline in those estimates of the marginal effect. But when we estimate the model with fixed effects, all right, so we can think about this as the permanent unobserved heterogeneity of individuals, then those things, the point estimates of the marginal effect fall, right, or the calculation of the marginal effect at the point estimates fall considerably, but they're also still significant for white women at the 10% level, but not significant for black women. And that's very consistent with what we see in the literature on this subject. One of the other things that the literature has been looking at is using...
These regressions that have black dummy in it, I guess, right?
Say it again? Yes.
It's the dummy variable. It's
No,
not on the table.
correct.
It's just the interaction.
Say it again?
No, just the dummy variable for being black.
Yes.
Separately from the interaction.
Oh, yeah. Sorry, yeah. And and I actually took out some of the variables to present here. In the paper, I've got those things listed. So we also did a quantile regression because that seems to be a good way to pick up different effects at different support of the distribution. And we do find that that the marginal effect of a health improvement is greater on wages as wages increase. And if we just calculate the average, we get about the same thing that we got with the OLS estimates. And if I use the conditional density estimation on the same model with no controls for selection or endogeneity or measurement error or anything, I get back essentially the same thing. So I'm just telling you that I can replicate what's in the data it's what's in the literature with my data. All right, so now think about estimation of this 17 equation system, dynamic system over time with the unobserved heterogeneity. So I'm accounting for the selection into employment, I'm accounting for the endogeneity of all of these right-hand side variables, as well as any measurement error, because this discrete factor technique can take care of that too. So what I'm presenting here is simulations from this model. And I should also point out that these are simulations with the updating. So I just give everybody their initial conditions. I estimate initial condition equations, but they're literally like reduced form equations, and so they always fit. So I give everybody their initial conditions and then just simulate forward. I let the model tell me or explain or predict your behavior in terms of schooling, employment, marital status, and child accumulation, as well as wages and evolution of body mass. And so you can see that it fits pretty well. And it captures, here I've shown you differences by black and white females. And just another thing just to point out, marriage rates are very different between blacks and whites, right, over the life cycle. Blacks tend to have children earlier in the life cycle than whites. There are lots of other graphs that I could show you. They have more children. They're losing children at a higher rate, but that's partly because they're having children earlier, so they're just aging out of the household. Black women are actually more likely to be employed than white women. And if we condition on employment, white women are more likely to be full-time employed. What else? Body mass, obviously the body mass of black females is larger. And in terms of hourly wages, we can see the difference across every age between the two races. All right. So how do we measure the contemporaneous effect? Well, that's just a simple derivative, all right? So we can easily do that with simulations. I can do it as a X% increase in BMI since I've got the continuous value. I can do it as just a 1 unit increase, or I can do what I've done in this example is go from overweight to normal weight, all right? So a health improvement, holding everything else constant. All right, so what do we get? So the dotted line, all right, is the model with no unobserved heterogeneity. So that's the simple model results. And here, rather than just showing you the averages that I showed you in the table earlier, I'm showing you the distribution. Oh, I should also point out, these are the deciles. So I'm using conditional density estimation, so I'm not using log wages that I used before. I'm estimating the whole density. And these are just values of the average wage within a particular partition. All right, and we did use 10 partitions in this estimation. So the red line represents, I think the average is 8 cents. No. Because that's the one with unobserved heterogeneity. The average is whatever it was close to that table. It's about 24 4 cents or something for white women and about 15 cents for black women. But then when we estimate the full model, and again, this is just the contemporaneous effect, we find that this is what the marginal effect looks like across the distribution of wages, but the average is about 8 cents for white women and essentially 0 for black women on average. But this is where I'm starting to get, what do I present, right? Because if we start talking about averages, then it kind of loses information.
What exactly is this? This is at an average across all ages?
It is across all ages. So the way I'm thinking about this is the wage distribution.
Of changing obesity, or this obesity index, just that period alone.
Well, every period. Right, but given that it's a contemporaneous effect, right, given that it's a contemporaneous effect, I take your observed X's, even on the endogenous things, I take your observed X's and I just change your body mass and just see what that is.
Average across doing that in all periods of space.
Right, because I'm thinking about this is the wage distribution that I care about theoretically, is you're going to get a draw from the wage distribution. I'm trying to estimate the wage distribution.
Ages or at a given age?
It's estimated as conditional on age, all right, but there's no age interaction with BMI, so it's just the marginal effect of BMI. But your wage distribution might be conditional on age. So if older individuals have a higher mean, right, they may be at a different place, and then because I'm using conditional density estimation, there might be a different effect of BMI for those individuals. So all that's kind of incorporated in there. This is
comfortable with the negative estimate over big range for blacks?
I don't know how to interpret it, right? I feel comfortable with the estimation that this is what it told me, but I don't know how to interpret it. So this is this is a health improvement, right? So these are people that are typically overweight. So if they were now underweight, so I don't know what this means, right? But that's what I find. All right. So now we care about the life cycle effect. All right. This is a little bit harder. So how can I simulate this from my model? So one thing that I can do is I can just let everybody be normal weight or overweight or obese throughout the entire life cycle and just calculate what the effect of that is. And that's actually what I'm going to show you today. But I could estimate individuals becoming like overweight early in the life cycle, all right, and then see what happens, versus someone who starts out in normal weight early in the life cycle. I could just let individuals steadily gain weight. So I could start them out at a BMI of 23 and just make it go up by 1. That's about 7 pounds every year, right? If we
expect cycles,
say it again?
Cycles, just like an addiction model.
I could do cycles. I hadn't even thought about that, but we could do cycles. All right, I could simulate anything, and that's what I want people to tell me what they want to see. I could let everybody be normal weight at age 18 and just let their body mass just evolve according to the model and just see how things change. All right, but then, yeah, I don't have anything about that. People are 18 to 23 when I first observed them. So I don't know anything about their early life cycle health.
I thought the literature indicated that was important.
Well, it's interesting because when I look at the coefficient estimates in the body mass equation, which is a function of your lagged body mass, that pretty much predicts everything. I mean, these other variables don't have much influence, or very few of them are statistically significant. So it is true, but I think more importantly, that this might have been important in the accumulation of schooling, whether you graduated from school or something, or especially these non-cognitive skills. But I just don't have that information.
Do you have like events that are stressful? You mentioned childbirth. There might be other events like unemployment.
Well, so I model non-employment. So that's in the model endogenously. I don't have like non-employment of a spouse. These are in the data. I don't know if I'd have that.
Death of a spouse or a child, for that matter.
Yeah.
Maybe mobility change.
Mm-hmm. No, those are.
These are things, changes like that. That might be stressful, might actually lead to greater weight gain.
Right. And so, and I mean, I could treat those as exogenous maybe too, and not worry about having to model the endogeneity of them. All right, but the other hard part is what simulation do you want to see, but also what outcome do you want to see? All right, so I can look at average wages over the life cycle, but I've already said that the whole point of doing this conditional density estimation is to get the density of wages. So I got to figure, I want you to see the density because there are differences across the distribution. So I could look at average or age 40 wages, or I could look at the age 40 distribution. I only got a couple more slides. So today, I'll just show you what the life cycle effect is of this reduction in weight over the whole life cycle, all right? So the solid line is the contemporaneous effect that I just showed you with the preferred model. My prior, all right, this was my prior going in. I should have mentioned this at the beginning. The whole reason why I wanted to do this is because I expected, let's say if we're talking about an improvement, that an improvement in health over the life cycle would lead to higher accumulation of human capital, and I pretty much expected that human capital would have a positive marginal effect in the wage equation. So the life cycle effect would actually be higher, all right, a higher wage improvement. And what I'm finding is it actually is smaller, all right? So the life cycle effect of this improvement is smaller than the contemporaneous effect. So why is that? All right. An additional year of education and work experience, remember I allow these to be different for blacks and whites, is about $1.15 and 85 cents for them respectively, and for work experience is about 27 and 30 cents. So if we go to what happens to those things, we see that, all right, so this is in the top panel, this is the difference in the effects of education experience. Why do I not have the effects on experience? Is this the one that I wanted to go to? Effect, wage impacts. All right, so, oh, this is just the marginal effect of experience. All right, so all right, we've got to finish. All right, so the marginal effect of experience is positive, or sorry, of education is positive, and you can see that it differs across the distribution of wages. The effect of experience is positive, about the same for black and white women, and differs over the distribution. But what happens to schooling, right? So these are differences. All right, so, and they're all positive. So individuals, when you have an improvement in health or a reduction in body mass, actually have higher levels of education in any year. All right, they actually have lower levels of full-time employment. I didn't show you being employed at all and part-time employment, but this is just an example of where the big differences are. So they're less likely to be full-time employed, and so this is one of the reasons why I'm getting this negative. And you can see that there are big differences between blacks and whites. All right, let me just, one more. All right, so then it made me start thinking, well, what's going on with marriage? All right, and so if we look at the impact of this improvement in health on marriage rates, white women are actually more likely to get married. All right, and I don't know if you can see, these are all positive numbers here, positive differences in the marriage rates, and get married earlier. Black women actually do increase their marriage rates, but at later ages. And in terms of kids, white women actually have fewer kids, and black women start out having fewer kids at younger ages than they previously had. All right, and then it goes to about 0. So I think what is going on is an improvement in health or a reduction in body mass is leading to higher marriage rates. And when you get married, you're probably more likely to have kids, right, which leads to less full-time employment. And so we're actually seeing that the lifetime effect is a reduction in the impacts on wages, right, rather than an increase in the impacts on wages. And so that's just capturing all of those dynamics. All right, sorry, thank you.
So I'm going to discuss Donna's paper with Una and Edward. What the paper sets out to do, I think, is pretty straightforward. It says they want to uncover what does body mass do to women's wages. Now, if you gain weight relative to your height, how is that going to affect your wages in several different ways? The first way they have is that there is a sort of a short-term effect. What happens if I weigh more today, holding constant my human capital variables? They call that the contemporaneous effect. And there's this sort of life cycle effect, which has in it this human capital accumulation effect. And I think one way to think about this is to say this is very similar to thinking about racial wage differentials if I were to control for something like occupation. Maybe part of the discrimination argument people make is that if I hold constant occupation, there's not much of a wage differential between blacks and whites. But part of discrimination is that blacks and whites get sorted into different occupations on the basis of discrimination. You might have it. So I think that's kind of the idea they're trying to get at the paper, is that the contemporaneous effect might not be the entire thing you want to look at. Rather, you want to see how the whole life cycle evolves. So unlike most of the earlier work in this literature looking at body mass index and wages, they're trying to take into account the fact that you get into a particular age with a set of human capital that's a function of how much body weight you have. So the contemporaneous effect they look at, I think there's three things you can think about. I think the first one is that body mass might be measuring some kind of human capital that we don't quite know what to call it, but it might be actually measuring something real. And so body mass is associated with this real thing. It's a proxy variable for some type of human capital measure. And that's the first thing they have. The second issue they have is it might be picking up some kind of unobserved costs that are faced by the employer or even by the individual, that say it's something like providing health insurance. And so body mass index might be measuring something like a cost to the employer that they might charge to the employee. And a third thing it might be doing is picking up employer preferences or employers' perceptions of customers' preferences. And if customers don't like overweight individuals, you may find there's going to be a wage penalty, or employers just don't like overweight individuals. There might be a wage penalty as well. You can think of that as being a discrimination component. The paper doesn't really distinguish among all of these, but I think we want to keep those into account because I think it might make I'm not sure, but I think it might make a difference in how we interpret some of the long time effects. So the body mass, or the life cycle effects, they work in lots of different ways in this paper. I mean, it's pretty amazing. It can affect how much schooling you have. It can affect whether you work or not, whether you work full-time or part-time, how it affects the accumulation of work experience. It can affect marital status and marital dissolution. It can affect the number of children, the timing of births in the family. And how the paper is set up is that each of these should be thought of as a demand or a choice by the individual throughout the life cycle. Now, I think, and I don't quite know how to address this, but I think all of these might be affected by the proxy, the cost, or the discrimination arguments we mentioned before. And I don't quite know what they mean, but I think that's something that the authors need to think a little bit about because it might change the interpretation of the results. I'm just not really sure. So let me tell you first what the paper does not do. There was a big change in the Americans with Disabilities Act in the early 1990s in the court case that said body mass should be considered a disability, so you can't discriminate against people. That happened, I think, in 1993 and 1994. That wasn't really brought into the paper. I suppose that's implicitly in the time effects they have, so maybe it's not a big deal. Since the main point of the paper is to discuss how body mass is affecting human capital accumulation, I was kind of surprised that they hadn't done a whole lot more in saying, let me show you what's going on. Here's what's happening at age 22, age 23. Did a little bit of that, but I thought there could be a lot more information presented to the people to see what's going on. The NLSY data has this weird feature in that in 1994 it started doing biannual surveys instead of annual surveys. They just sort of interpolate data. I don't know if that's the best way to do it. I don't have a great suggestion on a simple way to do it, but that's something I think you need to think about. And finally, they have this sort of quasi-identification where the body mass evolution equation depended only upon your contemporaneous decisions today, and it didn't depend upon things like labor market outcomes today, because those were already incorporated into the decision, did I work today, did I get married today, have another kid today? And I think that's a small limitation of the model because if we thought about this in a dynamic optimization framework, well, I might be picking my body mass today in expectation of what's happening tomorrow, and that might be affected by using, say, first-order Markov properties, predicting what's going to be facing the household or the woman in the subsequent year. So I think that's something you want to think about. These things are really proxying better for the life cycle approximation. You probably want to incorporate some information in that. So what's the paper doing? It does a whole lot, right? It compares fixed effects and ordinary least squares and random effects maximum likelihood estimates. The random effect maximum likelihood is a real massive undertaking, 17 equations each year. The wage and BMI outcomes are modeled extremely flexibly. There are 11 pages of coefficient estimates at the end of the paper if you want to get blown away by a lot of numbers. I don't know what they mean. There are 116 coefficients alone describing the wage distribution. I think I counted those correctly. I only did it once, but I didn't go back and recheck it. But this is not sort of the naive instead of run a random effects model. It's a much different model than that. And I think a way to think about it as a first-order approximation is that this is a very flexible parametric system of equations. It's like a limbal model or a Fimmel model, very nonlinear, and we'll talk a little bit more about it in a couple slides. What the paper does, it approximates the demand of the production functions as outcomes arising from optimal policy choices when the household or the individual is maximizing the expected present discounted value of utility at each point in time. Think of just maximizing the Bellman equation. I think a key part of what the paper does, it says, assume that all information about future distributions can be captured by variables observed today and in the past. And we'll see a little bit, an additional restriction on that in a couple seconds. Unlike more explicit structural approaches, like we've seen most of the last 2 days, this approximates the decision rules and production functions, and it'll give you estimates of what the household does, even if the household's following behavioral rules and isn't trying to maximize utility. So it's a very flexible approach. The random effects maximum likelihood estimator has permanent and transitory components. Donna went through all of this. I won't talk about it at all, but it's a very flexible specification. There's identification that exploits the time-varying geographic information on prices of education, prices of cigarettes, prices of all kinds of different foods. And this is at the county level, the state level over time. So there's lots and lots and lots of sort of exogenous variation if you buy that migration decisions aren't endogenous. There's a first-order Markov assumption that buys an enormous amount of identification here. There's today's variables, today's current state is measured by all the entire sequence of the past. There's just an enormous amount of over-identification. It's like some papers by Sargon and Bargava about 25 years ago. So there's a whole lot of potential over-identification in the model. So things I wish they had done. I think they could have related this a little bit better to the late IV literature. Test your exclusion restrictions. Show me that you have identification. Show me that that the model satisfies the over-identifying restrictions. Some of these are easy to do, some of these are hard to do. Secondly, highlight better the gains from using this estimation approach. Do something kind of like your table 6, estimate year by year instrumental variables equations and say, what am I gaining by doing all this extra work? I think that's possible. Put confidence bands in, compare the different effects. I think you'll find that this approach is probably much more robust and much more precise than sort of standard estimation procedures. Finally, what I wish they had done, I wish they had had a little bit more generality in how they let the unobserved factors enter into the model. A lot more computation time, but I think you get a lot more out of it. I'd like to see some of the unobserved factors interacting with key explanatory variables. They just tack these on as additive terms. Now, they're in somewhat nonlinear models, so they're not quite additive terms. And I'd also like to examine a little bit more closely how well the model predicts dynamics. For example, think of at age 40, there's some distribution of, say, spells of employment durations. How well do you match those? These are the kinds of features that you hope a dynamic model can pick up well. Final point, this is overfitting, and this is a little cheating here because it's not really something for estimation, but it is a graph in the paper. This is measuring age and BMI against wages. And what we notice is a lot of little blips here, and that's sort of, I think of that as being overfitting. And I'm a little worried about that in this model because 116 parameters describing wage distributions, even for 3,000 individuals over 17 years, might be too many parameters. So I think something like a penalized likelihood, a ridge approach, or a k-fold cross-validation to try to figure out how can you do this better might be a good way to do it. That will increase the computation time maybe by a factor of 1,000, but computers are cheap these days. And my computers do it all the time. So anyway, concluding remarks. I think they did a pretty good job at disentangling the contemporaneous effects of BMI from the life cycle effects. The results seem consistent with women are responding differently. They're making plans about the future using what's happening to their BMI. I have a huge wish they had done list because I think this is a really nice approach to use. I think for the types of questions she was asking here, it's a good way to proceed. I think you want to make it a little bit more convincing if you can. There's lots of uses for this approach. You can look at life cycle variations in mental health, or what happens for job loss, or what happens to different demographic and labor market outcomes. And the hook is coming, so I'll finish.
Thank you, Tom. I appreciate your comments. He did send me his comments earlier also, so we've had a chance to talk about it. I'm just going to mention 2 things. We, of course, did the checks for whether the exogenous variables truly did identify the model or not. I kind of take that as just given, and I forgot to report it. Right? I wouldn't have put them in there if they hadn't satisfied. I do have a question about how I would estimate this as an IV model. So I was thinking about Tom's comment. I mean, I could predict BMI and put in the predicted value of BMI, but there are lots of other endogenous variables, and it's not just accumulated years of schooling, which I could predict, but it's that whole vector of these endogenous variables that are summed by the modeling of the choices every period. And so I don't know how I would do an IV in this model.
Sure. I mean, at age 31, there's the entire history of prices that affect all of these variables and the interactions models. They aren't linearly separable.
We'll talk about.
So this is, we have, say, 15 variables each time period, 15-year history. That gives you a lot of over-identification.
Okay, I can think about how to do that. The other thing that I was going to say, and somebody kind of mentioned this, but nobody called me out on it. Tom mentioned the occupation, and I would love to include occupation in here also. And so I thought, but my co-authors and I thought about just putting occupation dummies in the wage equation, but I don't want to do that because I know that they're endogenous. And if I'm not going to model the endogeneity of occupation, because I'm not going to throw something in there that is endogenous and treated as exogenous, I think, well, what is it a function of? So it's jointly chosen with all these other things. Well, it would just be a function of what all these other things are a function of, which I do control for already. So I like your interpretation that maybe this is picking up some occupational choices since those aren't modeled. Thank you.
Question? Yeah, did I understand? So there wasn't much of an impact of this health improvement to lowering, right, on wages and so on, right?
I mean, there is a statistically significant effect.
Yeah, but it was small.
But
Economically, it wasn't very
80
important.
cents or something. It's a 1%.
But is that so? And one of your arguments was, well, increase the marriage rate and so on, all these things. So you interpret that as a pure beauty effect in some way, then, right? Because it's the value of marriage in the sense of getting a stream of income from your spouse didn't seem to change.
Well, it could be
much.
a beauty, or it could be a health. I mean, maybe people select individuals that are healthier because they're going to live longer or something, and so I don't know if it's a beauty or.
But this is BMI too, so it's got a beauty component to it. Sure.
Yeah, that's why I said I cannot. This significant wage effect, I don't have any interpretation of what that is. I'd like to think of it as health just because I'm a health economist, but it could easily be a discrimination, a taste, a beauty impact.
And when you think though too, and this was occurring for everybody was having, I mean, when you think of the marriage market, there's competition in the marriage market. So you have different impacts if it's happening to the entire population, whether it's happening to just a subset of the population. Right?
I do control for the ratio of male population of your race to female population of your race. Not that that's going to get exactly what you're thinking about, but yeah.
At what
I
level
agree.
of geography?
Say it again.
At what level of geography?
That's at that actually is at the state level, so it may not be relevant.
No.
I think I have it by count. Go ahead.
Did you test whether the Markov assumption for BMI is a reasonable assumption?
You know, again, as a health economist, whenever I think of the health production function, I always think of it as health and time T plus 1 as a function of your health and
Yeah.
time T. And so when
Well,
I model
for
BMI, I
example-
just model BMI that way also. I mean, that was my
There are
natural.
anecdotes about how people lose weight when they do,
Yeah.
which would not be Markov.
Yeah. So I'm actually, I mean, having looked at the results and looked at everything, and then obviously with Jim's comment about that people might cycle in and
Yeah.
out, I mean, I'm just wondering too if that was such a good choice.
But you could probably test it after fact easy, but
Okay.
right.
Okay. I'll do that.
You report moving from being overweight to normal weight. Did you also look at like moving from obese to just overweight or
Haven't.
severely obese? to
That's what
obese?
I'm looking for you guys to tell me what you want to see. But I can easily do it. Not easily, but I can do it.
There's a question over there.
So I was wondering, separating out the health effect from the discrimination effect, you mentioned that a friend of yours had discussed deviation from the mean for your racial group as a variable that you control for, but I was wondering if it could also be a treatment variable of interest, because you saw different effects that even the effect could be negative for blacks, so if people expect an overweight person, it may hurt your wages, this kind of thing, which would not be a health effect, that would be a discrimination effect.
Yeah, so I actually, in my analysis, not in the simple analysis, but in my analysis, I do control for this other variable, and it is statistically significant. And that's the reason why I kept it in. Tom was trying to convince me to take it out, because I have no idea how to interpret the coefficients now, because I've got body mass, and then I've got deviations from the norm of body mass, and they're not collinear. Tom's already asked me that. And so I mean, but I'm just, I can throw it in there, and I can see that it matters, but having a story for what's going on, I don't have that story, but.
So do your body mass effects, do you change that variable as well?
I don't
Something-
change that variable, so I assume that if I change, I mean, even though I'm simulating everybody to be of normal weight, I mean, I'm just assuming that there's still a whole bunch of people out there and your weight changes.
Then your relative weight will change too.
Across the two simulations, yes, so I do account for it there. But but the rest of the population doesn't change. Right. But I did simulate that.
The deviations, are they at a natural level?
They are just in the data, so I could go. I probably should go and just get the means for individuals and let those vary by the state level. Also, I should do that. I just took the sample in the data.